Hey everyone, in today's lecture we are looking at some example on power, work and energy, and this is the motion on an inclined plane that involves even energies stored in springs, and therefore we have got a guiding question that says a block of mass 5 kg is released from rest on an inclined plane as shown in the figure below. So we see there is a bumper here and the body is here of 5 kilograms. The inclined plane is at 30 degrees to the horizontal. The distance through which this body moves to the bumper is 0.8 meters. Find the maximum compression of the spring if the spring constant is 1 Newton per millimeter and the coefficient of friction between the block and the inclined plane is 0.2. Now for solutions, consider the forces involved. When you look at this, the equilibrium of an inclined plane, we have the body that is weighing 5 kilograms. So to get its weight, that will be 5 times g, which is the acceleration due to gravity, and it will give you 5g. So the weight acts vertically downwards. Then this weight has got a component along the inclined plane. Of course it is as a result of gravity, and it is 5g sine 30. Likewise, there is also another force that is due to the reaction here, and that force is equivalent to 5g cos 30. It is also another component of weight that is perpendicular to the inclined plane. Since the body is going to slide along the inclined plane down the inclined plane, then the frictional force, since it opposes motion always, it is going to act away from this body. Therefore, it is going to oppose its motion. Now, since the motion of the body is down the inclined plane at an acceleration a meters per second squared, then that means there is a force called the net force that is responsible for the motion of this body from here to there through the distance that we have seen. Therefore, we need to resolve forces along the inclined plane, and the net force that results into acceleration of that body is equal to 5g sine 30. When I look at this, it means the body is moving along here, so 5g sine 30 is greater than friction. Therefore, the net force that results into the body moving here and causing this acceleration is 5g sine 30 minus f. Therefore, that net force is equal to ma, mass times acceleration, according to the Newton's second law of motion, that says that the rate of change of momentum of the body is directly proportional to the force applied and takes place in the direction in which the force acts. And therefore, if we finalize and simplify that expression, we find that the force is equal to mass times acceleration. Also, we needed to note that frictional force F is equal to nu r, whereby nu is the coefficient of friction between the body and the surface of the inclined plane, and r is the normal reaction, which is already determined as 5g cos 30. So F will equal to nu times 5g cos 30, and therefore since nu is equal to 0.2, then we can substitute in that equation star. So that 5a, which is equal to the net force from force is equal to ma, mass is 5 kilograms and acceleration is a. So 5 times a is equal to 5g sine 30 minus 5g cos 30 times nu, which is 0.2. This acceleration is equal to 3.21 meters per second. Getting acceleration, it is telling us it is positive and moving along the inclined plane. We need to note that this acceleration results into a particular velocity also, because now when we look at the law of conservation of energy, we find that the kinetic energy of the body is taken to compress the bumper spring. In other words, when the body was at some point away from the bumper, it had potential energy. So if it was released to move to an acceleration a equal to 3.21 meters per second squared, it will attain a final velocity that results into the formation of kinetic energy, and which kinetic energy is going to be given out when it compresses or when it hits the bumper spring. Therefore, the kinetic energy K is equal to a half mv squared, whereby v is the final velocity, and from the third Newton's equation of motion, we find that v squared is equal to u squared plus 2as. We already know that displacement s is 0.8 meters. We know acceleration. We know it was released from rest. Therefore, u is equal to initial velocity is equal to 0 meters per second, and therefore v squared is equal to 0 times 2 times 3.21 times 0.8, and this v squared is equal to 5.136. Now this one has got units of meters per second, of course, squared. And if we substitute in the formula for kinetic energy half mv squared, we know mass, we know v squared, so it will be 12.84 joule. That's one. Then energy stored by the spring is equal to a half kx squared. Since we are dealing with the springs, then we need to recall of Hooke's law, that the force applied on that the force restored or kept by this spring is directly proportional to the extension of that spring. So F is equal to Kx. Now, because we know that the energy or work done is equal to force times the distance, which is x. Since we are looking at the compressing or extending the spring from 0 to some extension, then we need to take care of what we call an average force. So we take an average force, and therefore the energy will equal to F out of 2 times x, which is equal to kx times x out of 2, and this will equal to a half kx. So you need to note that we take average force when we talk about extending the spring or compressing it from 0 to some value. Then we need to look at the average force that is used to either extend or that is stored by the spring when it is compressed. So energy is given by kx squared according to the energy stored by the compressed spring. And since we know that we need to convert this into standard units so that we come out with units that are uniform, it means K is equal to Newton per millimeter, and this will equal to 1 Newton divided by 1 millimeter, and 1 millimeter is 1 out of 10 to the power 3 meters, which will automatically give us 1,000 newtons per meter. Now, since this is equation 2 and that is equation 1, and we have said this kinetic energy is equal to the energy stored by the compressed spring, therefore 12.84 is equal to a half times 1,000 times x squared, and getting the extension, getting the compression that the spring underwent after the body hit the bumper, then it will be 160 millimeter. Thank you so much for us in our next